So to better understand how to compute the pre-stress loss due to friction, let us apply it in a sample problem. A post-tension pre-stress beam has a span of 15.2 meters as shown. So this is the uh, the post-tension pre-stress beam. So obviously it has a duct placed first before the concrete is poured, and then after the concrete already attained its or after the concrete already attained enough strength, the pre-stressing reinforcement will be inserted. So the given is actually a simply supported beam that supports a uniformly distributed load W. So if the tendon is made of 7-wire uncoated strands in flexible metal sheeting, compute the frictional loss of stress in the pre-stressing wires due to the curvature and wobble effects. Assume that prior to transfer, the jacking force on the tendon was 0.75 FPU. So other information given on the problem is the cross-sectional dimensions on this particular location at midspan, which is equal to this. So these are the dimensions, and this is the eccentricity of the pre-stressing reinforcement at midspan. So it is already given. So a while ago, we still need to compute for this because the given distance is the distance of the pre-stressing reinforcement to the bottom of the concrete. Other given is the FC prime, FCI prime, FPU, APS, and EPS. And actually, the radius of curvature is already given, 42.672 meters or 140 feet. So for the solution, we first need to find the magnitude of the pre-stressing force that will be transferred to the concrete element at transfer when the pre-stressing reinforcement is already cut. So to find that magnitude of the pre-stressing force that will be transferred to the concrete element at transfer stage, we can use this formula. So the force that will be transferred to the concrete element is again not equal to the jacking force because there are some losses that occur on the tendon or the pre-stressing reinforcement uh, at the particular jacking stage. So as early as jacking stage, there are already pre-stress losses that are being experienced by the pre-stressing reinforcement, and one of those is the pre-stress loss due to anchorage. And another loss is actually due to the elastic shortening of the concrete, but we will just consider that if the tendons are jacked sequentially. Uh, but in this case, wherein there is no information if the jacking is done sequentially or simultaneously, therefore we can just assume that the tendons are jacked simultaneously. So therefore, there will be no pre-stress loss due to elastic shortening. Although it was already specified on the problem that the jacking force on the tendon prior to transfer at the instance wherein the pre-stressing reinforcement or the pre-stressing force will be transferred to the concrete element, it was specified on the problem that its magnitude is just equal to 0.75 FPU. Or since we want to find a particular force, we have to convert that stress here into corresponding force. So we have to multiply it by the area of the pre-stressing reinforcement. So substituting the corresponding values, FPU is given, the APS is given 99 mm squared each, and there are 10 of those 7-wire strands, so we have to multiply 99 mm squared by 10, and the product here will be in terms of Newton, so we have to divide it by 1000 to make it in terms of kilonewton, which is equal to this. So that will be the expected pre-stressing force acting on the jacking end that will be transferred to the concrete element at transfer stage. So after solving that, since we know that the formula for the magnitude of the pre-stress loss is equal to this, it is a function of this FPJ prime, which is what? Which is the stress acting at the jacking end at transfer, and uh, the factors that you see here, the mu, alpha, the k, and x. We have to find all of those magnitudes in order for us to solve for the pre-stress loss due to friction. So let us first solve for FPJ prime. So FPJ prime is just a stress acting on the jacking end at transfer. So since we already found the pre-stress force acting at the jacking end at transfer, we just have to divide it by the area of the pre-stressing reinforcement, which is 7 wire strand with 99 mm squared area each. So the result will be equal to this. So that is our FPJ prime. So for the other parameters needed, say for example, the alpha, we can use the formula that we have derived a while ago for finding alpha, the angle of curvature, which is equal to this formula that we have derived a while ago, 8y over x, wherein y is the distance between this line from the parabolic curve, distance from this line to the parabolic curve itself. And x is the distance from this end to this other end, which is just equal to the length of the beam. So substituting all of those values, y is just equal to e, which is equal to this. So we have to uh, express it in terms of meter, since the x that we will use here, the x distance between this point and this point is just equal to 15.2 meters. So we have to express this in terms of meter for consistency of units. So the resulting angle will be equal to this 0.1471 radians. So you have to remember that the angle that you will be solving here is in terms of radians. So that is for alpha. For the magnitude of x, obviously we can use the total length of the member, 15.2 meters. So meaning we will try to solve for the pre-stress loss due to friction from the jacking end to the other end with a distance x equal to the length of the beam, which is equal to 15.2 meters. For the values of the coefficients, specifically the mu and the k, we can use this table coming from ACI 318M-08. So since it was specified that the uh, pre-stressing wire is a 7-wire strand, and we can use the corresponding coefficients given on this table for 7-wire strand, grouted tendons in metal sheeting. So we can use this value here, the maximum value of K and the maximum value of mu, so that we will have a maximum value of pre-stress loss due to friction. So substituting all of those parameters on this formula, substituting FPJ prime, which is equal to this, and then mu, which is this, alpha, which is this, computed here, k equal to this, x is equal to this. Substituting all of those parameters here, we can solve for the pre-stress loss due to friction, which is equal to this. So this means that for a post-tension pre-stress beam, uh, we can expect that there will be a pre-stress loss with a magnitude of 178.91 megapascal that will happen, or that will be experienced by the pre-stressing reinforcement due to the occurrence of friction between the pre-stressing reinforcement itself and the surrounding concrete duct.